So to give you a background about the SIN list, ever since we started this in 2008, the SIN list has been all about providing answers. And as you know, we are a small NGO and we follow the debates and trends. And back when REACH was just in the start of it, together with some other European NGOs, of which many are here today, we listened, and one of the first questions obviously was this one. What chemicals can we expect on the REACH candidate list? A question asked by both companies and governments and more or less everyone. What does this mean in practice? So this is what we tried to answer. We listed substances fulfilling REACH criteria to be substances of very high concern, SVHCs. And by doing this, we provided something concrete and something to relate to, because endpoints and half-lives don't mean very much to most people. So even if we agree on and understand the criteria, we want to know what this really is in terms of chemicals. And by having this list, we had something concrete that you can understand and you can communicate about it. And it was a success. And a few years later, in 2011, there was a question that is still being asked actually, but that was coming up more and more. And it was this one. What are the endocrine disrupting chemicals that we must keep track of? In the lack of political action, everybody wonders, what should I do about EDCs, especially as a company? What does this mean? And we could, without having the criteria legally in place, we could still, by using scientists, identify a number of endocrine disrupting chemicals that most scientists would agree that these are endocrine disrupting chemicals. And again, we had something concrete and something to relate to. And today, that list of endocrine disrupting chemicals is still one of very few available concrete lists. And it's been recognized, for example, by UNEP for being robust and scientific and reliable. And it proved to be really helpful. And if we look at the timeline of the SIN list, we've had a few larger events. And we can also see that the user base has doubled in the last 5 years. And if we look at who the user is, as the SIN list is completely free of charge, you don't have to log in, it's completely open. We don't really know who uses it unless they tell us. But we can see a few things, like where they're from. And if we look 1 year back from now, the top countries to use the SIN list has been France, US, Sweden, Spain, and Germany. And this fluctuates a little bit over the years, but this is 1 year back from now. And we can also see the chemicals that are the most searched ones on the SIN list. And interestingly, this is of course not obvious to everyone, but these are all among our SIN listed EDCs that we added. But if we sort of leave the past behind and we think about the future, what are the questions that the SIN list will answer today? So one thing that we've heard also among the keynote speakers today and more recent years is this discussion about forever chemicals. Chemicals that are persistent, meaning that they do not degrade in the environment, but they stay on for a long time. And PFAS, that has been mentioned much, perfluorinated and fluorinated chemicals, are sort of the poster child chemical group for these forever chemicals. And we have realized that they are all over the globe. We find them in the Mariana Trench, and we find them in polar bears, in the Arctic regions. And as a fact, there is nowhere on Earth you can sort of escape the persistent chemicals, the forever chemicals. And then, of course, you ask, or people ask, so why are those not regulated? And in part they are. In REACH, we have criteria to regulate persistent chemicals if they are also bioaccumulative, meaning that they they accumulate in fatty tissues, in organisms, and they tend to be higher concentrations the higher up in the food chain you come. So we, as a top predator in many cases, as humans, tend to have quite much of these chemicals in ourselves. And we have added persistent, bioaccumulative, and toxic chemicals to the SIN list once again, because that's a really important group, and we saw that we don't have all of the important ones on the SIN list. And so today we will add 16 more PBTs to the sin list. And we have PFAS as one example. We have azo compounds, mainly UV filters there. We have aromatic amines and heterocyclic compounds. They are often pigments. And all of these are sort of found in all kinds of everyday products. You know that PFAS is used in textiles, in cooking ware, in firefighting foams, in food packaging, and it's the same for many of the rest as well. UV filters are used in a number of applications, pigments, and so forth. So we feel it's really important that we tackle those chemicals today. But the question is, does this really cover the issue with the persistent chemicals? And actually we think it doesn't. So that's why we have also looked into the concept that has been proposed by the German Environmental Agency, UBA, to look also into the persistent chemicals that do not accumulate in organisms, but that are very water-soluble, so-called mobile, the PMTs, that are transferred in waters that we find them in groundwaters, in drinking waters, in surface waters, and the water agency, they do not manage to clean them out because they are so persistent and they are difficult to tackle. And yes, GenX was the chemical to be the first PMT chemical that was added to the sin list this summer. Which was very interesting. It is a Teflon replacement that has been found very much, especially in the Netherlands. And so we have this already a little bit ongoing, that PMTs are recognized more and more. And therefore you wonder, of course, what are the other PMTs to look out for and to substitute first? So we have added also 16 of those to the sin list. And again, we have PFAS chemicals also in this category. We have chlorinated solvents, organophosphorus compounds, heterocyclic compounds, highly reactive compounds. Again, compounds that are used in all kinds of consumer products, detergents, washing powder, all kinds of things that we have in our houses and in our homes. But that becomes a big problem once they're in the water cycle as well. And today I have with me great experts. I'm very happy for that. It was earlier announced that we should have Nanette from UBA to present the idea behind the PMT criteria and why that's needed. But I'm very glad that we instead have Hans-Peter Arp, who has actually done very much of the background work for UBA, to talk about that. And then I have also Martin Scheringer, who has done the scientific evaluation of the specific chemicals, both in terms of the PBTs and the PMTs, that is the persistent chemicals, the forever chemicals. So this is quite nice, huh? And you could think that that's quite a big thing, and it is, of course, but there is one more question, actually, that the sin list will answer today. And that is a question that has been nagging us for a long time. Ever since the first version of the sin list, this is a discussion has come up over and over again. And it's a bit difficult, but now it was actually time to see, can a nanomaterial be categorized as an SVHC? And so what is nano? Nano is a size. It's the size between 1 and 100 nanometer, and sort of any particle in that size would be a nanoparticle. And what makes nano so interesting and difficult is that the small size of the particles can give very different properties to the same material if you have it in a larger form. So you would have unique, interesting properties from a technological perspective, but you might also have unique, interesting properties from a toxicological perspective. And what we sort of know is that we cannot say in general that nano is always a problem or always good. It will be different from material to material. And we can also not say automatically that a substance that is safe in a big form is safe in a nano form, or the other way around. So it's a completely different issue to tackle. And the discussions around nano tends to circle around, especially in the regulatory arena, everything that we do not know, everything we need to investigate. And also difficulties to characterize what we are actually talking about. But there is one example, at least, one example where we have enough information to say that this is a nanomaterial with SVHC properties, and that is carbon nanotubes. And Steffen Foss-Hansen will talk more about that, how we investigated that and came to the conclusion that carbon nanotubes as a group are carcinogenic, persistent, and probably toxic to reproduction as well. So that's a really problematic material to handle. And with that, I would like to invite the experts, and after that I would like to invite you all, when you come home, to look into the new SynList website. We have updated the website and the database with new functions and new information to make it even easier for you to sort of understand the background and also filter and use the SynList for your purposes and for your interest. So,
okay.
Thank you very much.
Thank you.